Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter relations and functions. So if you have any questions or uh, doubts regarding any question or its solution, then please write us in the comments section. Um, and if you feel that you have more difficulty in any particular chapter, then also please mention it in the comments section, so that we can solve more and more questions on that chapter. And homeworks on every chapter will also be uploaded on the Sapience education application. So please install our Sapience education application, whose link has been provided in the description. Okay, so we shall start. So in the previous uh, part, we had solved from question number 1 to question number 26. So we shall start from question number 27 here. So here it is told that f of x, the function f of x, that is equals to 2x square. And so we have to find the value of f of 3.8 minus f of 4 by 3.8 minus 4. Okay, so f of 3.8, so f of 3.8, that would be obviously 2 into 3.8 square, and f of 4 would be equal to 2 into 4 square. So this will be equal to 2 into 3.8 whole square minus 2 into 4 square divided by 3.8 minus 4. So from here 2 I can take as common, and this would be 3.8 square minus 4 square divided by 3.8 minus 4. So this would be 2, and we know that a square minus b square equals to a plus b into a minus b. So this formula we can use it here. So this would be 3.8 plus 4 into 3.8 minus 4 divided by 3.8 minus 4, a plus b into a minus b. So this 2 would cancel. So the answer would be 2 into 3.8 plus 4, which is 7.8. 7.8 into 2, that is equal to 2 8 just 16, 2 7 are 14, that is 15.6. So option D is the correct answer. Option D is the correct answer. Okay, then so then we shall go on to the next question, which is question number 28. So here it is told that let f is a function which maps from R to R. So R is the set of all real numbers, and which is defined as f of x equals to 1 by x for all x belongs to R. Then f is onto or not defined 1 1 bijective. So if it is bijective, it means it should be both 1 1 and onto. So we have to find if it is 1 1 or onto. So here f of 0 is not defined. F of 0 is not defined. So 0 has no image. So therefore all real numbers except 0 can be obtained. So the range of the function f will be equal to the domain of the function f, that will be equal to r minus 0, since 0 cannot be obtained. But here 0 has been included, so hence the range is a subset of the so it is 1 1 obviously, since if I take f of x1 equals to f of x2, where for all where x1 and x2 belongs to r minus 0, it should not be 0 actually. So then 1 by x1 equal to 1 by x2. So then I can say x1 will be equal to x2. So it means that it is 1 1 obviously. So the function f is 1 1 but not onto. It's 1 1 but not onto. since y 0 has no image. Okay, so option B, sorry, 28. So here R has been told as the domain. The domain of the function has been told R, but f of 0 is not defined, so we should tell that the function f is not defined in the given interval R. Since why we should tell the domain as R minus 0. So therefore option B is the correct answer. Then here f of x is given as half minus tan pi x by 2, where x is greater than minus 1 and less than 1, and g of x is equal to square root of 3 plus 4x minus 4x square. So this one should be greater than or equal to 0. Therefore 3 plus 4x minus 4x square, that should be greater than or equal to 0 always. So we can say that it is okay, so this is 4 minus 4x square minus 4x plus 1, we can tell, that is greater than or equal to 0. So it means 4 minus this, we can write it as 2x minus 1 whole square, a square plus b square minus 2ab. Okay, so that is greater than 0. So it means that 2x minus 1 whole square, that should be less than or equal to 4. It means that 2x minus 1 should be greater than or equal to minus 2 and less than or equal to 2. It means that 2x should be greater than or equal to minus 2 plus 1, that is minus 1, and less than 3. It means that x should go from minus 1 by 2 to 3 by 2. So the domain of f plus g, that should be the intersection of this domain and this domain. So here it is told for the function f, x is going from minus 1 to 1, and here x is going from minus half to 3 by 2. This is, so the common intersection region we have to take, the common domain of f and g, that is minus half to 1. Here 1 is excluded, so therefore x should be greater than or equal to minus half and less than 1. Therefore x should belong to the interval minus half to 1. 1 is excluded, so therefore option C is the correct answer. It means the domain of f plus g should be the intersection of the domain of f and the domain of g, that is option C. So in any of the steps, if you are unable to understand or any doubts you are having, then please write us in the comment section. We shall obviously clarify them. Okay, then in question number 30, that is, if the operation, excuse me, so if the operation plus with a circle around it, okay, the operation plus with a circle around it, it is defined as a operation b, that is, we can call it as some operator, we can call it as the operator symbol, actually operator symbol. So simply we can call it as operator. So a operator b, that is equal to a square plus b square for all real numbers a and b. Then 2 operator 3 operator 4, that is equal to, you have to find it. So therefore that will be a operator b, that is a square plus b square. So this will be 2 square plus 3 square and with that we have to take the operator with 4. So 2 square plus 3 square, 4 plus 9, that is 13. So 13 operator 4, that is equal to 13 square plus 4 square. So that will be equal to 169 plus 16. So that will be, we can tell it as 170. So okay, so 6 plus 9, that is 15. 2 plus 6 8, so 185. 185. So the option B is the correct answer. Okay, so then if f is a function which maps from R to R, is defined as R is a set of real numbers, of all real numbers, and then it is defined as f of x equals to x by x square plus 1, and we have to find the value of f of 2. Now therefore f of 2 that will be equal to 2 by 2 square plus 1, that is equal to 2 by 4 plus 1, that is 2 by 5. Now therefore we have to find f of 2 by 5. F of 2 by 5, that is 2 by 5 divided by 2 by 5 whole square plus 1. So that will be equal to 2 by 5 by 4 by 25 plus 1. So therefore f of 2 by 5, that would be equal to 2 by 5 into, that would be 25 by 29. So that would be equal to 5 5 is a 25, 5 is a 10, 10 by 29. So option A is the correct answer. Hope you have understood. Okay, then the set A has 4 elements. So the number of elements in the set A is 4, and number of elements in the set B, that is 5. Then the number of injective mappings that can be defined from A to B is injective mapping. So it should be 1 1. So in A, in the set A, and here we have set B. So set A contains 4 elements and set B contains 5 elements. Set B contains 5 elements. So these 4 elements should map with any of the 4 elements in B, since it should be 1 1. Here it should be 1 to 1 mappings. 1 to 1 mappings only should be formed, since it is injective. So any 4 I can choose by, from out of these 5 elements in the set B, we have to choose any 4 elements by 5C4 ways. 5C4 ways, and that into 4 factorial we can do, since those 4 elements can be rearranged also. So therefore it will be 5p4 actually. So that will be 5 factorial divided by 5 minus 4 factorial, that is 1 factorial. So that is 5 factorial, which is equal to 5 into 4 into 3 into 2, that is equal to the 20 into 6, that is 120. 120. So 120 injective mappings can be there from the set A to the set B. Okay, so the option D is the correct answer. Then let f is a function which maps from the set R to R. R is the set of all real numbers, and the function f of x is defined as 2x plus 6, which is a bijective mapping. Then f inverse x is given by, so f of x, so if I tell f of x1 equal to f of x2, so then we will get x1 equal to x2. So it means that it is 1 1, and all real numbers only is the range. So range is the same as the co-domain. Range is equal to the co-domain. Therefore it is an onto function. So therefore it is both 1 1 and onto. So it is a bijective mapping. It is bijective mapping. So if it is, so since f is bijective, so I can say f inverse will exist. It means that f is an invertible function. So now therefore we can take it as y will be equal to 2x plus 6. So I can tell 2x will be equal to y minus 6, which is, so x will be equal to y minus 6 by 2, which is equal to f inverse y. X is equal to f inverse y. So therefore f inverse x, that will be equal to, simply we have to replace y with x. will be x minus 6 by 2. That is equal to x by 2 minus 3. So option A is the correct answer. Then it is told here, let star be a binary operation which is defined on the set R. So it maps from the set R cross R to R. So it means that both the inputs should be real numbers and the output, which is A star B also should be a real number. So A star B also should belong to R for all A comma B belongs to R. So then it is called as a binary operation on the set R. So here A star B has been defined as A plus B by 4. Then the operation star, we have to find if it is commutative or is it associative. So here B star A, therefore B star A, that is equal to B plus A by 4. That is also same as A plus B by 4. So that is same as A star B. So hence star is commutative. So therefore the operation star is commutative, binary operation. And we have to find if it is associative or not. So A star B star C. A star B star C, so that would be equal to A star B star C would be B plus C by 4. A star B plus C by 4 will be A plus B plus C by 4 divided by 4. So that would be 4A plus B plus C by 16. And then A star B star C. So that would be equal to A star B is A plus B by 4 star C. So that would be A plus B by 4 plus C by 4. So that would be A plus B plus 4C by 16. So they are not same for all values of ABC. So therefore we can say that star is not associative. Star is not associative. Star is not associative. Since why? Since these two are not equal. Since A star B star C is not same as A star B star C. So therefore the operation star is commutative but not associative. Is commutative but not associative. So therefore the correct answer is option B. Okay. Then it is told that let f is a function which maps from the set R to R. It is defined as f of x equals to x power 4. Then you have to find if the function is 1 1 or onto or not. So therefore x power 4 will be always greater than or equal to 0 for all x belongs to R. So for all real numbers x power 4 will be always greater than or equal to 0 only. Since it is a square number, it will be a square of something. Since we can write it as x square whole square. So it will always be positive or 0. So therefore here the range of the function f, that is from 0 to infinity, which is obviously a subset of R. So range is a subset of the codomain. Range is a subset of the codomain of the function f. So hence the function f is not onto. The function f is not onto. And if I tell f of x1 equal to f of x2, for some x1 and x2 belongs to R, it means that if x1 and x2 both are real numbers, so then x1 power 4, that should be equal to x2 power 4. Now if I x1 power 4 x2 power minus x2 power 4 will be equal to 0. Then if we factorize this, then we will get x2 square minus x1 square into x2 square plus x1 square, that is equal to 0. Then we can say that x2 minus x1 into, okay, so from here we can say that x2 square plus x1 square should not be 0, since both are not equal. Okay, it will happen only if x1 x2 both are 0. So then x1 square will be equal to x2 square if both x1 and x2 are not 0. Then it means that x1 should be equal to plus or minus x2. So it means, suppose for example, if we have like f of minus 2, that will be also equal to minus 2 whole power 4, that is equal to that is equal to 16, and f of 2 also will be equal to 16. So therefore f of minus 2 equal to f of 2, but minus 2 is not equal to 2, so therefore the function f is not 1 1 also, is not 1 1. So therefore the function f is neither 1 1 nor on 2. Therefore option B is the correct answer. Okay, then so we shall go to the next question, that is the binary operation star on the set R minus minus 1, that is defined by a star b, that is equal to a by b plus 1, a by b plus 1. So we have to find if it is associative or commutative or not. So now R minus minus 1, since we cannot include minus 1, since b plus 1 should not be equal to 0, so b should not be equal to minus 1. So we should exclude the element minus 1 from all real numbers, from the set of real numbers. So now b star a will be equal to b by a plus 1. B by a plus 1, that is not same always. Suppose for example if you take that 2 star 4, 2 star 4 will be equal to 2 by 4 plus 1, that is equal to 2 by 5. But 4 star 2 will be 4 by 2 plus 1, that is equal to 4 by 3. So they are not the same. Therefore star is not commutative. Therefore the operation star is not commutative binary operation. And then if it is associative, we have to find a star b star c. A star b star c, that will be a star b star c will be b by c plus 1. So a star of that will be a by b by c plus 1 plus 1. So that would be a into c plus 1 by b plus c plus 1. And then a star b star c, that would be equal to a by b plus 1 star c. So that would be equal to a by b plus 1 by b plus 1 by c plus 1. So that they are not the same. A by b plus 1 into c plus 1 we should write them. So suppose for example if I take like 1 star 2 star 3, 1 star 2 star 3, so that would be 1 star, so that would be like 1 into 3 plus 1 by 1 2 plus 3 plus 1, that would be 4 by 6, which is 2 by 3. But 1 star 2 star 3, that would be like 1 by 2 plus 1 into 3 plus 1. So that would be 1 by 3 into 4, 3 for the 12, so which is 1 by 12. So they are not same. Therefore the operation star is not associative also. It is not associative. So therefore the operation star is neither commutative nor associative. Neither commutative nor associative. Okay, so option B is the correct answer. Okay, then so in any of the steps, if you're unable to understand and any doubts if you're having in any question or in the solution, then please write them in the comment section. We shall clarify those in the subsequent live classes. Okay, so then here the range of the function we have to find, f of x, that is equal to square root of 9 minus x squared. So here 9 minus x square, that should be greater than or equal to 0. So but here, so it means that x square should be less than or equal to 9. X square should be less than or equal to 9. It means that square root, now x square will be always greater than or equal to 0 always. X square is greater than or equal to 0 and less than or equal to 9. So therefore we can say that x square, so minus x square will be greater than or equal to minus 9, less than or equal to 0 for all x belongs to real numbers. Okay, so x square should be greater than or equal to minus 9, 0. So then if I add 9, so then 9 minus 9 less than or equal to 9 minus x square, that is greater than or equal to 9. So then if you take the square root on both all sides, that is square root of 0, that is less than or equal to square root of 9 minus x square, that is less than or equal to square root of 9. So therefore square root of 9 minus x square, that is greater than or equal to 0 and less than or equal to 3. So therefore the range of the function f will be from 0 to 3. Both are included. So option A is the correct answer. Then the next question here, f of x equals to 8x power 3 and gx, that is g of x, that is equal to x power 1 by 3. And we have to find f of g of x. So that is equal to 8. So that is f of g of x. So it means that we have to do 8 into g of x whole cube. So that would be 8 into g of x, that is x power 1 by 3 whole power 3. So that is 8x. So that is 8x. So option C is the correct answer. And then let f and g be two functions which map from R to R, where R is the set of all real numbers. These are two functions defined as f of x is defined as mod x plus x and g of x is defined as mod x minus x for all x belongs to R. Then we have f of g of x for x less than 0, we have to find that. So now therefore g of x is mod x minus x. F of g of x for x less than 0. So f of g of x, so here f of g of x that we have to find. So that will be, in place of ax here we have to use g of x. So that is mod of g of x plus g of x. So we know that so x is less than 0. So when we know that when x is less than 0, then mod x is written as minus x. So therefore then g of x will be written as mod x minus x, that is equal to minus x, that is minus 2x. So this will be written minus 2x, then g of x will be minus 2x. So therefore f of g of x, that is equal to mod of g of x, mod of minus 2x, where x is negative, then minus x will be positive, then plus g of x, which is minus 2x. So this will be minus 2x only. Since x is negative, so minus x will be positive. So this will be minus 2x, that is minus 4x. Okay, so then it is minus 4x. So option C is the correct answer. Then here it is told A is a set having 6 distinct elements. So the number of elements in the set A is 6. 6 different elements are there. The number of distinct functions from A to A which are not bijections. So from the set A, if we the total number of functions that is possible, the total number of functions possible, that will be 6 power 6. Since why? Each and every element can map with each and every element in the set A can have any of the 6 elements as the pre-image. So each element in the codomain can have any of the 6 elements in the domain. So each element in the codomain has got 6 options. So there are 6 elements. So 6 elements will have 6 power 6 options. So six options for every element. So 6 power 6. This is the total number of possible functions. But here it is told the number of distinct functions which are not bijective functions. So first we can find out how many bijective functions are there, and that we can subtract from this, and then we will get those functions which are not bijections. So set A to set A, we have to map a function from set A to set A, it has been told. So it has 6 elements. Here also it has 6 elements. So if we have to form a bijective function, bijective mapping we have to do from the set A to itself, then it should be 1 1 and on 2. Should be 1 1 and on 2. So we know that if it is 1 1, it will be automatically on 2. Since why there are 6 elements in set A, we should map with 6 elements in the set A itself. So if it is 1 1, it will be automatically on 2 only. So we have to find how many 1 1 means how many injective functions can be made. So each of these 6 elements can be rearranged in 6 factorial ways. So 6 factorial bijective functions can be made. 6 factorial bijective functions can be formed. So therefore, the total number of functions which are not bijections, are 6 power 6 minus 6 factorial. So it is option C. Option C is the correct answer. Okay, then let f be a function which maps from R to R. R is a set of real numbers and which is defined as f of x, which is equal to 2x if when x is greater than 3, and it is x square when x is greater than 1 and less than or equal to 3, and it is 3x when x is less than or equal to 1. Then we have to find f of minus 1, f of 2 plus f of 4. So now therefore f of minus 1, that is equal to, so when x is less than 1, then we have to use the third definition. This third definition we have to use when x is less than 1. So since minus 1 is less than 1, so we have to use this definition only. So that is 3 into minus 1, and that is minus 3. And then f of 2, so 2 is a number which lies in between 1 and 3. So we have to use the second definition, which is x square. So it will be 2 square, that is 4. And then f of 4. So 4 is greater than 3. So we have to use the first definition when x is greater than 3. Since 4 is greater than 3, obviously. So 2 into 4, this will be, so 8. So therefore their sum we have to find f of minus 1 plus f of 2 plus f of 4. So that would be equal to minus 3 plus 4 plus 8. So that is 1 plus 8, that is 9. So option A is the correct answer. And then f is a function which maps from R to R. R is a set of real numbers, and G is a function which maps from the set 0 to infinity to R. It is defined as f of x equals to x square and g of x equals to x square root x. So here x should be obviously greater than or equal to 0 for g of x. So that is why the domain of the function g should be from 0 to infinity. And the domain of f is R, since why all real numbers should be there. All x can be any real number here. Which one of the following is true? Now g of f of 4. G of f of 4 means g of f of 4. So that would be root over f of 4. Root over f of 4. Now it will be root over, so f of 4, that is equal to 4 square. 4 square, which is 16. So root over 16, that is 4. So g of f of 4 is 4. So here it is told which one of the following is not true. So first one is true, so option A is not the answer. So now f of g of 2, that is equal to f of g of 2. So g of 2, that is root 2. So that is f of root 2, that is equal to root 2 whole square, is also equal to 2. So therefore B is the correct answer. So B is not the correct option, since B is true. And option C is f of g of minus 4, that is equal to f of g of minus 4. So that is equal to, now g of minus 4 is not defined. G of minus 4 is not defined. Not defined. Since why? Since the number minus 4 does not belong to the domain of the function g. Minus 4 does not belong to the set 0 to infinity, which is the domain of the function g. So therefore g of minus 4 is not defined. So f of g of minus 4 is not defined. The answer will be not defined, but it is written 4. So option C is the correct answer, since why option C is false. It is not 4. It is not equal to 4. The answer should be not defined here. And then the option D also, if we want, we can check. That is, it is written g of f of minus 2. That is g of f of, now f of minus 2, that is minus 2 whole square. That is minus 2 whole square. That is 4. So g of 4, that is equal to root over 4. That is 2. So D is true. Therefore D is not the option. So option C is the correct answer. Then question number 43. It is told that if A is a set which consists of all those x such that x is a natural number and x is less than or equal to 5. So therefore A contains the elements 1, 2, 3, 4 and 5. If you write it in the roster form, if you write the set A in the roster form, and then the set B, that is, it consists of all those x such that x belongs to z. Z is the set of all integers, and then x square minus 5x plus 6 should be equal to 0. So now if we factorize it, then we will get x square minus 5x plus 6, that is equal to 0. It means that we can do x minus 2 into x minus 3, since 2 3s are 6 and 2 plus 3 is 5. X minus 2 into x minus 3, that is 0, and then x equal to 2 and 3. So therefore the set B contains the elements 2 and 3 only. So then the number of onto functions from the set A to the set B. The number of onto functions from the set A to the set B. 1, 2, 3, 4, 5 it has the set A to the set B. We have to find onto functions 2, 3, 2 and 3. So it means that any so 2 can be the image of 1 or 2. So we should have 1 to many relation is not a function. So we should have actually many to one function. we should have many to one function. Since the number of elements in A is more than the elements in B, so we have to have many to one function, so as to be onto function. So then so so here 2 can be mapped with um, so here it means that the first element 1 can have 2 as its image or 3 as its image. So every element has two options. So every element in set A, the set A has two options, 2 or 3. It can be mapped with 2 or 3. But all the elements cannot be mapped with 2 and all the elements cannot be mapped with 3. So these two possibilities we have to exclude. So therefore, the answer will be 2 power 5 minus 2. 2 power 5 minus 2. Since why these two I should subtract, since these are the two cases. These are the two cases where the function is not onto. Two cases where the function is not onto. Since why in these two cases all the elements in the set A are mapped with 2 and in the second case all the elements are mapped with 3. So those two cases I should remove. Since why in that case the function will not be onto. So it means 2 power 5 minus 2 we should do. So that is 32 minus 2, that is equal to 30. So 30 onto functions can be found. 30 different onto functions can be made. So option B is the correct answer. Option B is the correct answer. So now then on the set of positive rationals, a binary operation star is defined as A star B, that is equal to 2AB by 5. Set of positive rationals, it means that both A and B should be rational number. A and B belongs to Q plus. So therefore star is a binary operation on the set Q plus. It maps from Q plus cross Q plus to Q plus. So then both are positive rational numbers. So now if 2 star x that is equal to 3 inverse. 3 inverse means 1 by 3, then x is. So it means it is 2x, 2 into 2x by 5, that is equal to 1 by 3. So therefore x will be equal to, this is 4 by 5, so that is 5 by 12. 5 by 12. So therefore in question, so 2ab by 5, that is equal to 3 inverse. Therefore now 3 inverse, it means the inverse of 3. Inverse of 3, the inverse element. So here A star E, that is equal to E star A, that is equal to A. Then E is called as the identity element. E is called the identity element. E is called the identity element. So here x is not 5 by 12 actually. So here inverse of the element 3 that we have to find. So E is called the identity element, and if A star A inverse, that is equal to E, then A inverse is called the inverse of the element A. Inverse of the element A. So now here if I do A star 5 by 2, A star 5 by 2, then that will be 2 into A into 5 by 2 by 5. So that will be equal to A. So therefore 5 by 2 is the element E. 5 by 2 is the identity element. Now therefore 3 star how much? So 3 star, suppose so 3 inverse, that is equal to 5 by 2. So it means 3 inverse that we have to find, inverse of the element 3. So it means that 2 into 3 into 3 inverse by 5, that is equal to 5 by 2. So therefore 3 inverse, that will be equal to 5, 5 is 25, 25 by 4, 3 is 12, 25 by 12 is 3 inverse. So now therefore we have been asked to find 2 star x, that is equal to inverse of the element 3. So that will be 2 into 2x by 5, that is equal to inverse of the element 3, that we have found it as 25 by 12. So that is 25 by 12. So therefore x will be equal to 5 into 25, that is 125 by 12 for the 48. So x is 125 by 48. So option D is the correct answer. Okay. So in any of the steps, if you are unable to understand, then please any doubts if you are having, then please write us in the comment section. Then question number 45, the domain of the function f such that which maps from R to R, which is defined as f of x equals to square root of x square minus 7x plus 12. Okay, so we have to find the domain. So then here x square minus 7x plus 12, that should be greater than or equal to 0 actually. So it means that if we do the if we factorize it, then we will get x minus 3 into x minus 4, that is greater than or equal to 0. So if we plot them on the number line, then this is 3, this is 4. So if we take some value which is more than 4, then it is coming positive. So positive, negative, positive. So therefore x should belong to the interval minus infinity to 3 union 4 to infinity. Since in this interval only this function will have here, this will have positive value, and then only the function, the output will be real. Then only f of x should be real. F of x belongs to R. So therefore minus infinity to 3 union 4 to infinity. So option A is the correct answer. Okay. Then here it is told if n of A, if it means the number of elements in the set A, that is 2, and the total number total number of possible relations from set A to set B is 10, 1024, then n of B is how much? N of B, that is how much? So number of elements. So the rule is that if the number of elements in set, the rule we have to use, that is if number of elements in the set A is n and the number of elements in set B, that is m, then the number of possible relations from the set A to the set B is given as 2 power mn. This is the rule. Since why? Since the Cartesian product of A cross B, if A has n elements and B has m elements, then A cross B will have mn ordered pairs. Mn ordered pairs means m into n elements it will have. So now here we can have so all the subsets of A cross B, all the subsets possible. The rule is that all possible subsets of A cross B, of the Cartesian product of A and B, are the total possible relations, are the total number of possible relations possible relations from A to B, from A to B. So all the set of all possible subsets, it means that we can choose, so we can have the subsets of A cross B, so we can have null set, and we can choose any of the ordered, any one of the ordered pair from Mn. So MnCC1, any one we can choose, and then MnC2, so any two I can choose, or any three ordered pair I can choose. So null set, it means that we are choosing, we are not choosing any ordered pair. It means MnC0 I can tell. So therefore it will be MnC0 plus MnC1 plus MnC2 plus till Mn. Since why all the ordered pairs also I can choose, it means that the entire Cartesian product A cross B, or the universal set which is A cross B, can be chosen as the A cross B will be called as the universal relation from A to B. This will be also one possible relation, and null set also I can choose as one of the relation from A to B, which is called as the empty relation. Empty relation. So it means that the sum of all these, it will be equal to 2 power mn. So 2 power mn are the possible relations from A to B. So now here it is told, here the number of elements in the set A, that is equal to 2, and let the number of elements in the set B is equal to m, suppose. So then the total number of possible relations, will be possible relations from A to B. So total number of possible relations from A to B will be equal to 2 power 2m. So that is given as 1024. The number of possible relations from A to B is 1024. So therefore it means 2 power 2m. Now 1024 means it is 2 raised to the power 10. So it means that it will be 2m, that is equal to 10. So it means m should be equal to 5. It means that B should have 5 elements. So the option C is the correct answer. So now, in question number 47, it has been told that let f is a function which maps from the set 2 to infinity to R. This be the function defined by f of x equals to x square minus 4x plus 5, then the range of R. So now this can be written as x square minus 4x plus 4 plus 1. Now this can be written as x minus 2 whole square, a square plus b square plus 2ab, so plus 1. So now f maps from 2 to infinity. It means that it is told that the domain of the function f is 2 to infinity. It means that x should be greater than or equal to 2. So if x should be greater than or equal to 2, it means that x minus 2, that is greater than or equal to 0. So x minus 2 whole square also will be greater than or equal to 0. So x minus 2 whole square, that plus 1, that should be always greater than or equal to 1. So the range will be from 1 to infinity. So I can say that the function f of x, it is always greater than or equal to 1. Therefore I can say the range of the function f, that is actually from 1 to infinity. 1 is included. So option A is the correct answer. Then if a relation R on the set this, let's say we call it as a set A, which is 1, 2, 3. So therefore R maps A to A. R is a relation from this on the set A to A. It is defined by R, which is 1, 1. Only one element, one ordered pair is there. Then R is what? So here 1, 1 is there, but 2, 2 does not belong to the relation R. So 2, 2 or 3, 3 does not belong to the relation R. So I can say that R is not reflexive. R is not reflexive. And then we can tell that now 1 comma 1 is there, but 1 comma 2 does not belong. 1 comma 2, it means that a1 comma a2 does not belong to the relation R for all a1 comma a2 belongs to A, where a1 not equal to a2, where a1 not equal to a2. So if a1 is not equal to a2, it does not belong to the relation R. So it means that R is symmetric. R is symmetric. Since why, if a1 comma a2 belongs to the relation R, then it implies that a2 comma a1 should belong to the relation R also. So here 1 comma 2 is, if it is there, then 2 comma 1 also should be there. But since a 1 comma 2 is not there, so we don't have to think that 2 comma 1 is there. So it is not necessary that 2 comma 1 should be there. So it means that R is symmetric. And then a1 comma a2 and a2 comma a3 does not belong to the relation R, where for all a1 comma a2 comma a3 belongs to the relation A, where a1 is not equal to a2, which is not equal to a3. So if all are unequal, so these kind of elements are not there. So it means that R is transitive. R is transitive. So it means that the relation R is transitive and symmetric but not reflexive. So it is symmetric and transitive. So option B is the correct answer. So in any of the questions, if you cannot understand any of the steps of the solution, or any other doubts if you have regarding the question, regarding the statement of the question, or in the explanation of the solution, then please write us in the comment section. Then we shall solve the last question of our live class. So A is equal to ABC. A is the set which contains the elements A, B, C. Then the number of binary operations on the set A. So the rule is that if there are m number of elements, if there are m number of elements in the set A, it means that we can say that n of A that is equal to m, then the number of possible binary operations, the number of possible binary operations on the set A. It means that if star is a binary operation on the set A, it means A cross A maps to A. R, it means the number of possible binary operations on the set A is given as m power m square, m raised to the power m square. Since why A cross A, since the Cartesian product A cross A, it will have m square ordered pairs. It will have. It means that the number of ordered pairs in the Cartesian product A cross A, that will be equal to m square. So now, therefore, all the subsets, of the ordered pairs means A cross A comma A, means that this m square element should map with m elements. So each of the elements in the set A, here A cross A is a set of m square ordered pairs. It should map with all the elements in the set A which have got m elements. So each of these elements can have m square options. So m number of elements will have m raised to the power m square options. It means that each element has got m square options. So m elements will have m power m square options. So m power m square subsets will be there of the set A. Okay. So m raised to the power m square binary operations can be formed. So here, here we have number of elements in the set A, that is 3 here, A, B, C. So therefore the number of possible binary operations on the set A operations will be equal to 3 power 3 square, is equal to 3 power 9. 3 power 9 it will be. So option C is the correct answer. So hope you have understood all the solutions of the questions, and if you have any doubts then please write us, and any other chapter if you feel that it is it seems to be difficult for you to solve, then please write the name of that chapter also in our comments section, then we shall solve more and more questions on that. So thank you everyone. So the live class is over. Bye. Thank you.